Section 3.4 Energy. When you're running, walking, dancing, or thinking, you are using energy to work, and any activity that requires energy. In fact, energy is defined as the ability to do work. Suppose you're climbing up a steep hill and become too tired to go on. At that moment, you have no sufficient energy to do any more work. Now suppose you sit down and have lunch. In a while, you have obtained energy from the food and you will be able to do more work and complete the climb. Kinetic and potential energy. Energy can be classified as kinetic or potential energy. Kinetic energy is the energy of motion. Any object that is moving has kinetic energy. Potential energy is determined by the position of an object or by the chemical composition of a substance. A boulder resting on the top of a mountain has potential because of its location. If the boulder rolls down the mountain, the potential energy becomes kinetic energy. Water in a reservoir behind a dam has potential energy. When the water goes over in the dam and falls to the stream below, its potential energy is converted to kinetic energy. Foods and fossil fuels have potential energy in their molecules. When you digest food or burn gasoline in your car, potential energy is converted to kinetic energy to do work. Heat and units of energy. Heat is associated with the motion of particles. A frozen pizza feels cold because heat flows from your hand into the pizza. The faster the particles move, the greater the heat or thermal energy of the substance. In the frozen pizza, the particles are moving very slowly. As heat is added, the pizza becomes warmer, the motions of the particles in the pizza increased. Eventually, the particles have enough energy to make the pizza hot and ready to eat. SI units of energy. The SI unit of energy in work is the joule. The joule is a small amount of energy, so scientists often use the kilojoule, or 1,000 joules. When you heat water for 1 cup of tea, you're using about 75,000 joules, or 75 kilojoules of heat. Table 3.7 shows a comparison of energy in joules for several energy sources. Energy used to sleep an hour, 10 to the 5 joules. Energy used for serving a pasta, a donut, or needed to cycle an hour, 10 to the 6 joules. Energy from 1 gallon of gas, 10 to the 8 joules. Energy used by one person in a year, 10 to the 11. Solar energy from the sun to the earth, 10 to the 17 joules. Energy consumption for 1 year in the US, 10 to the 20. World reserves of fossil fuels, 10 to the 23. And energy radiated per the sun per second, 10 to the 26. You may be more familiar with the unit calorie, from the Latin caloric, meaning heat. The calorie was originally defined as the amount of heat needed to raise the temperature of 1 gram of water 1 degree Celsius. Now 1 calorie is defined as exactly 4.184 joules. This equality can be written as a conversion factor, 4.184 joules per calorie, or 1 calorie per 4.18 joules. A kilocalorie is equal to 1,000 calories, and 1 kilojoule is equal to 1,000 joules.